All right, so you can write the x and the y coordinates of each point on a curve as a function of a third variable. So what we must make a note about this is that firstly, we have variables x, y, and now a third variable t in this particular function. And instead of a coordinate x, y, you can have something that's in terms of t. So this could be like t squared, maybe, and y could be t plus 1, for example. In which case, as t changes, these values will change in its own way, creating a unique set of coordinates identified by, in this case, a parabola in a straight line, but on an xy plane, which is weird, but it comes together in a nice example. Let's say we've got a curve has parametric equations x equals to 2t and y equals to t squared. And we're given that t moves from negative 3 up till 3. The first question we asked is to find the Cartesian equation of the curve. So we want to find the Cartesian equation of the curve in the form y equals f of x. And then to do this now, this first part here, what we're going to do is we know that x is equal to 2t. So we can make t the subject of the formula and it'll become x over 2. And that'll be equation number 1. And then we have y equals to t squared. So we can rearrange that as well. Actually, we can substitute x into y and square it. So it's going to be x over 2 squared because that's t. And so that becomes y equals x squared over 4. And now we have the combined function, which is a quadratic in this case. All right, so find the Cartesian equation. The Cartesian equation will be that, which is a parabola. So we combined these two functions. That's how the x and y values will be changing. It ends up as a parabola. And the second function, or second part of this question says, write down the domain and the range of this. Now we can see that there's limitations on t, which means there'll be limitations on the domain and there's limitations on the range. That's pretty easy. All you have to do is substitute it in to each. So if I want to find the domain, I must remember t can go up till negative 3. So if I take negative 3 and I substitute it in there, it'll become negative 6. So x will be greater than negative 6. If 3 goes in there, it'll become 6. X will be less than 6. And then negative 3 goes in here, it becomes 9. Y is greater than 9. Negative 3 goes into there, and you'll find it's going to be equal to 9 again. So what do we do in this case here? So we're saying that if we're substituting negative 3 in for y, it's becoming 9. If we're substituting positive 3, it's becoming 9. But the next question is, okay, so well, what would the actual range for y be? Or maybe I should not use this. Maybe I should use that and rather substitute the x values in there. If I did that and I took negative 6 and I put it in there, that's going to become 36 divided by 4, which is going to give me 9. And if I put 6 in there, it's going to become 36 divided by 4, which will still get me to the same thing, 9. But the range of f, all right, the range of f is the range of the parametric function of y. And so we have to be careful because if you look at y equals t squared in itself, I could possibly take a value in between the two. So I got -3, -2, -1, 0. And the moment I move across 0, all of these values become unique because everything on the left hand side is going to be exactly the same as everything on the right hand side of 0 because I'm squaring it every single time. That means if I start from t equals 0 and I put it in there and then move onward until 3, that's going to be the only valid points that will exist. So instead of substituting the extremes, I can start from 0 to get unique values. So I put 0 in there, I'm going to get y is greater than 0 and it's less than 9. And if I go the other way, it will go from 0 to 9 as well, in between the -3 and the +3 on a number line. So y becomes greater than 0, but less than 9. And the next thing is we should also use greater than or equal to 0, all right, because it can equal 0. It is possible that t is equal to 0 in this interval. And because t is equal to 0, y should also be equal to 0 as well from that. And that'll be the domain over there, and that was the range there. The domain and range done. The next question says sketch the curve within the given domain for t. So now we want to sketch this curve in the given domain for t. So if we're sketching the curve, we're going to be sketching y equals x to the power of 2 over 4. And we said that the domain goes from -6 until 6. The range goes from 0 up till 9. And we're having a parabola. If I make x equal to 0, then y will equal 0. So we know 0, 0 is the point where it's going to probably turn because there's no p value, there's no c. So when we sketch this, it's got to go through 0, 0. And it's going to turn there because that's my x-intercept and it's my y-intercept. So it's going to be turning at that point. It will start at -6, it will end at 6, and it will go up till 9 over there. All right, and that would be the sketch of the curve. Done. All right, so example number 2. A curve has parametric equations. Let's make it a little finer. Has parametric equations. And they've given us x equals to ln t plus 3 and y equals to 1 over t plus 5. And t is greater than -2. Find the Cartesian equation of the curve of the form. So the first one we're going to do is we're going to find the Cartesian equation. And we're given that it's in the form y equals to f of x. And we have x is greater than some constant k to be found. So whenever we want to find this part, what we have to do is we take the first equation, x equals to ln t plus 3. And the second equation, or we actually have to make t the subject of the formula. So we raise both sides to the power, we raise both sides as a power of e. And in that way, we cancel out these two, giving me t plus 3 and e to the power of x on the left. And then subtracting it on the other side gets me t equals e to the power of x minus 3. And now that I have this on this side, I can then substitute t into the second function. So the first step is to make t the subject. And then the second step is to substitute t in here to get y. So that we have a function of y and x. Okay, so we're going to sub into y equals 1 over t plus 5. And that's going to come to y equals to 1 over e to the power of x minus 3 plus 5, which means it's going to become 1 over y equals e to the power of x plus 2. When t is equal to negative 2, then x is equal to ln t plus 3, which will become ln 1. So at some point, we know that if we're calculating this over here, we can substitute that in there. We can substitute that function in there, that number in there. So that's going to be negative 2 substitutes in for t over there. So anyway, the original part of this question, we were told that t is greater than negative 2, and that is what we're going to use to get the domain and the range. So even though we have the function, we now need to identify how this will affect x. So if t is greater than negative 2, if I substitute negative 2 into this function over here, it will become ln of 1. And so if t is equal to negative 2, then x will equal ln negative 2 plus 3, which will equal ln 1. So x will equal 0. So we know the domain for this would be, like t is greater than negative 2, x will be greater than 0. So the final function would be y is equal to 1 over e to the power of x plus 2, where x is greater than 0, just giving the identification that of the range, right? I mean, of the domain, x greater than 0. All right. So we found the Cartesian equation, which is part A. Part B, it says write down the range of f of x. So part B says write the range of f of x. The range is your y values. So if we're working out our y values, what we want to have is substitute that t into this function over here. So y will equal 1 over t plus 5. And if t is equal to negative 2, then y will equal 1 over negative 2 plus 5, which means y will equal 1 over 3. And if t is equal to 2, if t is greater than negative 2, then we can see that by substituting negative 2 in here, we get plus 5, we get 1 over 3. And as t increases, in other words, if we had a number line and this was t, and we had negative 2, negative 1, 0, 1, and as I put 0 in there, it becomes 1 over 5. I put 1 in there, it'll become 1 over 6, 2, 3, 4. You'll find that 1 over t plus 5, as t goes to infinity, this denominator will become infinity, in which case the whole fraction will tend to 0. So we can see that as t continues, it's going to end up at 0. And obviously, if it goes in the other direction, it's going to go to 1 over 3. So the first thing we need to do is say, okay, well, as t increases, y decreases. As t increases, y decreases. But it will always stay positive. So the range ends up between 0 and 1 over 3 as we test it. Because negative 2, remember, is it's going to be greater than negative 2. So we're starting over here and we're working our way towards that side, which means that our starting point would be 1 over 3 as it works its way to 0. It's actually going in the opposite direction, but that's because of this function in the form of 1 over t plus 5. All right, so that's a parametric equation. We found the Cartesian equation of each of those for that.